Welcome to the second video of the fourth phase in this series on how to perform supervised classification using ERDAS IMAGINE. In part 1 of this phase, we used the set a threshold method to evaluate our classification. In part 2 of this phase, we will use the accuracy assessment method. With the accuracy assessment method, the analyst compares certain pixels in the classified thematic raster to reference pixels for which the class is known. This is an organized way of comparing the classification with ground truth data, previously tested maps, aerial photos, or other data. Let's begin. Load the source raster image into a 2D viewer and into a second viewer. From the Supervised Classification menu, select Accuracy Assessment. The Accuracy Assessment cell array contains a list of class values for the pixels in the classified image and the class values for the corresponding reference pixels. The analyst enters the class values for the reference pixels. The cell array data resides in the classified image file. In the Accuracy Assessment dialog, click File, then Open to open the classified image dialog. Select the Supervised Classification image. This is the classified image file that is used in the accuracy assessment. In the accuracy assessment dialog, click Select Viewer, then click in the view that is displaying the continuous raster image. In the accuracy assessment dialog, click on View menu and select Change Colors. In the Change Color dialog, the points with no reference color patch should be set to white. These are points that have not been assigned a reference class value. The points with a reference color patch should be set to yellow. These are points that have been assigned a reference class value. Click OK in the Change Colors dialog to accept these default colors. The analyst can also change the colors should they wish to do so. Now we can proceed to add the reference points to the image. ERDAS IMAGINE allows users to either generate random points or import their own points whose classes are known. In the Accuracy Assessment dialog, click Edit, then choose Create or Add Random Points. In the Add Random Points dialog, we can either keep the default value or enter a number in the Number of Points fields. For this demonstration, we will find 10 random points. To perform a proper accuracy assessment, you should generate 250 or more random points. Confirm that the search count is set to 1024. This means that a maximum of 1024 points are analyzed to see if they meet the defined requirements in the Add Random Points dialog. Set the distribution parameters to random. Click OK to generate the random points. A list of the points is shown in the Accuracy Assessment cell array. In the Accuracy Assessment dialog, click View and select Show All. Wait a few moments for all random points to display in the view. Note that the points will have the color specified earlier. In this case they are white, since we used the default color settings. Now we will compare the corresponding pixels in the continuous raster image to the supervised classification image. Open another 2D view and load the supervised classified image and display its table to view the color and class names. Activate the viewer containing the continuous raster image and spatially link and sync it to the other viewer containing the supervised classified result image. In the Accuracy Assessment cell array, select the first point. From the Accuracy Assessment menu, click View, then select Show Current Selection. The corresponding point is now the only point showing in the view. Zoom in on the thematic image until you can clearly see the point and the underlying pixel. In the Accuracy Assessment cell array, note the class number specified for that point. In the Attribute cell array for the thematic image, locate the corresponding class number and color. Now zoom onto the point in the continuous raster image and note to which class this pixel belongs to. If the pixel underlying point 1 in the thematic image seems to be assigned to the proper class, enter the same class number in the reference field of the Accuracy Assessment cell array. If the pixel underlying the point in the thematic image does not seem to be assigned to the proper class, enter the correct class number. As you enter a value for a reference point, the color of the point in the view changes to yellow. Do that for all the random points. In the Accuracy Assessment dialog, click Report, then Options. Ensure that the error matrix, accuracy totals, and kappa statistics options are all checked. In the Accuracy Assessment dialog, click Report, then Accuracy Report. Then again from the Report menu, select Cell Report. The Accuracy Assessment report opens in another ERDAS IMAGINE text editor. The report lists the options and windows used in selecting the random points. If you want to keep them, save the cell report and accuracy assessment reports in text files. Close both ERDAS IMAGINE text editors. In the Accuracy Assessment dialog, click File, then Save Table to save the data in the cell array. The data is saved in the classified image file. Close the Accuracy Assessment dialog. If you are satisfied with the accuracy of the classification, clear the image from the view. If you are not satisfied with the accuracy of the classification, you can also use the thematic raster layer in the image interpretation options, raster attribute cell array, and spatial modeler to modify the file. That's it for this series on how to perform supervised classification using ERDAS IMAGINE. Please drop any questions you may have below, or if you have any suggestions on other topics you would like us to cover. In our next series, we will be looking at machine learning and deep learning classification in ERDAS IMAGINE. Remember to subscribe to the channel and hit on the bell icon to get automatic notifications every time we upload a new video to our channel or to this series.